It's good to have you join today's webinar from whatever time zone you're joining us. It's 1 p.m. West African time. Good afternoon to you. My name is Ademola Victor, and I'm glad to be your moderator for today's Scaling Your Startups Application on AWS webinar, put together by Secure Intelligence Limited. If you can hear me, can you just use the emoji signs, give me a thumbs up, or just respond one way or the other, so I know you can hear me loud and clear. All right, I see some thumbs up over there. Thank you very much. In today's webinar, we would have our facilitator take us through how we can scale various working applications using the vast resources available on the AWS platform. So we'll just run through some certain housekeeping rules, and we go right into the webinar. Our facilitator and previewed is already in the house with us. This session is being recorded, and bits of it will be uploaded on our various social media channels. We seek your indulgence to know that this is not to infringe on your privacy, but also to share the vast knowledge that would be available in this webinar to a larger audience. Attendees can react or raise their hands during presentation. Other engagement required from attendees would be at the discretion of the facilitator or myself. If you have questions during the course of this presentation, we encourage you to please use the Q&A session to ask your questions, and we would do well to answer them. Let's talk a little about Secure Intelligence Limited. Secure Intelligence team is a team of solution builders. We apply technology to drive effectiveness, agility, and growth for businesses. We are positioned to help enterprises scale globally. Interestingly, today's webinar is giving an overview of what we represent as an organization. How do we achieve this? We achieve this using the various values, implementing the various values you can see on the screen here: our global mindset, our multi-cloud competence, our agility, strength, and our growth values. These are the ways we achieve the goals we set out, which includes helping your organization, helping startups to scale globally. Today's presenter is no other person than James. We call him Teddy in-house. Teddy, please confirm if you are on the call and you can hear me loud and clear.
Hello, Victor. Good afternoon. Can you hear me?
Good afternoon. So I'll pass the mic over to you for today's presentation. Over to you, Teddy.
Thank you, Victor. Thank you for the introduction. Hello, everyone. Good afternoon. I'm currently in the afternoon in my time zone. Good day to everyone. I'm Teddy. I'm James, also known as Teddy. If you guys could hear me, please could you kindly raise up your thumb, just like Victor suggested, so I'll be able to know you guys are with me. Oh dear. Okay, thank you. I can see some thumbs. Thank you for that. Okay, so on today's webinar, we'll be speaking on scaling applications on AWS, right? Our applications, during the session, we'll be talking on a lot of things, including understanding application scaling. Why is there even need for scaling application? How to know when to scale your applications. When is the right time to scale your application? What's the idea behind it, right? How to scale and considerations. Basically, what's the considerations behind scaling your different applications? If you have the applications, okay, you want to scale now, you're taking the decision you want to scale. How do you go about scaling? What's the consideration behind it? Scaling on AWS. Now we'll be tailoring the different solutions AWS to particular scaling platforms, you understand? So just generally speaking, like horizontal scaling on AWS, where we'll now go into the demo where I show you how the scaling is done on AWS and an example, basically. and some of the tools we use on AWS on the scaling. All this could also be done by consultants, which are actually in secure intel, which we are in secure intel. Please, could you go to the next slide? Okay, so by the end of this webinar, this is what our take home will be: a solid understanding of AWS scaling concepts, insight into the best practices for scaling AWS applications and applications in general, real world examples and case studies. What we'll talk about the different case studies of various applications that we currently make use in our day-to-day, and how scaling has actually affected them, planning for scaling and the rest. The ability to assess and adapt your startup's AWS infrastructure for growth. If you have your startup on AWS, right? If you have your application on AWS, how do you scale these applications you currently have? How do you go about the scaling? What kind of tools you need? Everything will be discussed in this webinar. Please, the next slide. Next slide, please. Okay, so understanding application scaling. Basically, application scaling refers to the ability of an application to handle growth or an increased workload. Generally, increased number of users, that's how people refer to it as, but it's a little more detailed than that, and still provide the same functionality. So basically, the whole idea of scaling would be, I've built my application out, right? And my application is currently serving 1,000 users, for example. If that users grow exponentially, say I have 10,000 users, 100,000 users, would the application still work the same? Would the application not break? Would there be performance issue with the application lag? That is, would it be lagging bit by bit, whereby if the more users, it is working quite fine, but it will be a little bit slower, performance issue-wise, you understand? Okay, what about, for example, let's say the users are actually doing a lot of things. Would it cause application downtime? I've noticed, I'm sure we all have actually been in a situation whereby we actually went to applications online and we could see something went wrong. We can access the application, and you're quite sure you got the URL of the application quite right. These are the issues we'll be facing in this particular webinar, and how to the case study on how to go about them. I'll mention real life examples of various applications we currently make use of, and how they've actually encountered things like this, and what's the idea behind things like this. How did they actually did work on stuff? How did they mitigate all these kind of issues, and henceforth? Please, could you go on to the next slide? Okay, so how to know when to scale? Initially, I actually mentioned scaling, right? I mentioned what scaling is and the idea behind scaling, right? Before we get to that, right, I want you guys to know that you have to actually select the right application, the right building your application on the right infrastructure would actually help you scale better. A very good example is if you don't actually plan the right architecture to build your applications on, scaling that particular application will be actually a lot of issues for you as a developer or as a startup founder. If you have an application and you've not actually planned it out on saying, okay, you just built an application, it's working fine, and you want to be a startup, you're not assuming there's going to be more income coming in, more traffic coming in, everything is working quite fine. Okay, another good example is, let's say we're on an e-commerce site, for example. We're on an e-commerce site, we sell stuffs. Basically, people come to our application, our web application, either through the mobile or web application. People come around, people try to buy stuffs, people order stuff from us and we deliver to them. What about occasions where there are traffic spike? We are currently in November, right? Most stores does I think it's Black Friday is on every November, whereby every Friday they reduce there's a huge discount on what they have, and so you could buy anything you're buying for, let's just say 8,000, goes down to 500 for the same price. So basically, people would like to take advantage of all those kind of opportunities, which means there'll be more people actually coming to that application. Is your application able to withstand that workload? Other things you should take into consideration would be, if these people can't get these stuff on your application, if you have users, right, and your users can't actually get what they need from your application, they are going to patronize other people. Basically, you are losing customers, and that's not ideal for startups. As a startup, you're not even supposed to lose even a customer. You're supposed to please everybody at the same time. You can't afford to lose people, because startups basically are based on word of mouth. if somebody could have a good experience with you, with your startup, I say the person will tell another person, that person will tell another person. Basically, that's how you get your customers as a startup. So scaling your application is actually quite essential to your application as it is. So how do you know when to scale? First of more traffic. We've discussed on more traffic, more users to the application, right? You come to the application, there are 5 people on the application when you initially started out, 500 at the end of the month, 5,000 in 3 months. Let's say in 6 months, you get to 1 million plus. A very good example, if for some of us that are like into techie things, you would have heard of ChatGPT, OpenAI. ChatGPT was released to the internet. I've forgotten the particular day, but it went from 0 users to 1 million users in 3 days flat. Day 1, day 2, day 3, 1 million users in 3 days flat. What kind of, do you believe your application could still stand strong or stay strong if it received that amount of users within that specific period of time? How do you think your application is still going to like withstand all those kind of traffic, right? On daily basis, Facebook have millions of users, Twitter have millions of users, Instagram has millions of users. Yeah, this application still function well. We use WhatsApp every day to day. This application still function well. But occasionally there are downtimes, right? I'm not sure this is the first, second, or third time. Especially this year, there's been once or twice this year where WhatsApp has been actually down, and users have noticed. And these users go to other applications to complain. You see users come to Twitter, come to Facebook, come to different applications to say, hey, I'm trying to send a message on my WhatsApp and it's not going through. Is WhatsApp working at your end? Then everybody it goes to be a widespread. If for WhatsApp, they could actually handle that. Why? Because they have a very large customer base and most people use them in their day-to-day life, which means sooner or later people are going to come back, right? That's the idea. But if you're a startup, right, and this is the first time I'm trying you out, and I go to your website or I go to your application and I try to do something and it's not going through, the very first idea I get is, nah, these people are not working, these people are not doing the right thing, these people are just there, they're just playing around, right? So downtimes, right? If you've been having a little bit of downtime, you should know that's the right time to scale. Something is not right with your application. You should have almost zero downtime. I'm not saying totally zero is almost impossible, but almost zero downtime. Slow performance. Every time is not necessarily for your app to be actually totally offline, but occasionally your app might be very, very slow. You might try to do something and it's kind of like it's taking a lot of while to actually get that thing done. Just to view a picture, just to scroll down the app. And it's not the network on the particular user, but the user knows it's not his or her network. If the application is too slow, they would definitely go to another person that does the same thing that you do. That is how people work. That's how customers work. The faster, the better. So slow performance should let you know that, okay, there's something wrong with my infrastructure and I should actually bring it up. Events. I've made mention of event earlier on, whereby I say during a particular period of time, there is actually spike in customers. There's spike in users using the application, right? There's spike in traffic. That's during the where I made mention of the November thing, the Black Friday, whereby people come online to buy more stuffs at reduced discounts, whereby you see more than 2-3 times your normal user. Those are the periods you get normal new users to your application. Other things that are actually not covered here on this particular how to scale will be customers, right? Sometimes user experience. Users might reach out to you and tell you, okay, your application could actually be better in a certain kind of way. You understand? So customer feedback could also be part of knowing how to scale. Hello everyone. If you have any questions or you want to say anything, you could actually drop your questions in the income message. Just in case if there's a question between, so that I'll be able to answer the question. Okay. What about if you're growing? What about if you're changing your business perspective? You're changing your business values. You have the particular value of your business, and you're like, okay, I want to implement a particular kind of business value, which will actually require me to go into the application to do a little bit, 1 or 2 things on the application. Basically, if the application is not built for scaling, it will break the application down. I think back in 2012 or so, or 2013, there something happened on Netflix, right? Netflix went down. Netflix went down for a period of, I think, hours, up to 7-8 hours. And it was estimated that they lost almost millions of dollars within that period. They lost almost millions of dollars within that short period of time, right? And again, Netflix is a big application. They could actually come back from that. If they come back up, people are going to come back up. But another thing, if you know, is at the same time, they are going to lose a little bit of customer because Netflix has very, very strong competitive market. We have Amazon Prime, we have Disney Plus. There are a lot of streaming, basically, there are a lot of other streaming options, right? And if you're down for that long, or if you're down for too long, for wait consecutive period of time, people won't be using you. People won't use you because they believe I could always get this stuff from somewhere else. So why am I using this particular customer? So basically, you guys could see the total essential of scalability in an application, the need for scalability in an application, and the idea of knowing when to scale in an application. The next slide, please. So on the next slide, right, we'll be talking about how to scale. Scaling can come in majorly two ways. Scaling are definitely defined in majorly two ways. There are more ways than this. We're going to touch on that. But generally, scaling are majorly defined in two ways, either vertical or horizontal. I'm going to explain why both ways and the consideration you should do before thinking of one particular way of scaling, right? Before approaching your scaling performance through one particular angle or method. Now, vertically means just basically upgrading what you have. A very good example, you have a laptop or you have a phone and the phone is lagging a bit. What do you want to do? You want to increase, you have to increase the RAM of that phone, basically change it for a bigger phone. That's what they tell you. So basically that's what vertically is. So now let's say we have a RAM of, let's say 2 gig on our a RAM of like 2 gigabytes on our database, as an example, on our database. If I see that, okay, to perform queries on the database, that is for users to actually look through various stuff on the database, is a bit sluggish. The users is taking time for the users, right? Slow performance. Now it's not like the users, not like it's not going through at all. It's going through, but it's taking time. Understand? It takes a while before the users get their response, which basically means it's lagging. You have the option of scaling vertically. Now, what does that mean? It means, okay, since it is slow, I can actually increase the RAM from that 2 gig to, let's say, 8 gig. Then basically, it becomes exponentially faster. Very, very much faster. Let's just say, initially it's taking around 30 seconds to complete just one process. It might go from 30 seconds right down to 6, 7, 6, 8 seconds. You can see how fast it is, right? You can see how fast it is scaling up vertically. So basically, what vertically means is substituting the memory in that particular option. Remove what you have, or just increase what you have from what it is to something higher, something a little bit higher. Why a little bit higher? Just to increase, just to make it faster, basically, to make the things work faster. One of the issues with vertical, I'm going to tell you why each part has considerable issues. One of the issues with vertical scaling would be it is still a single point of failure. What I mean is still a single point of failure. If you have just one database and your application, you have a mobile application and you have an application online, and both of them are connected to that one database, I hope you all know what a database is, right? If you don't, you could just say no in the income message and I'll go over it to explain. So we have one single database and the application is performing a slow query. That is, we're looking up users and it's taking a little bit of a while. Then we increased it and it went down from 30 seconds, like I mentioned earlier, to something around the likes of 7 seconds, 8 seconds. Okay, let's say we decide it's even still slower. Then we increase it again. Then it went down from 7 seconds to maybe 2, 3 seconds to perform to get a user. It's very fast now. We're okay with that. But it still represents a single point of failure, which means if anything happens to that database, everything we have is gone. The application is down. You understand? It doesn't stop the application from not going down. What it just does is help you increase speed. But on the plus side of it, right? What it does for you at that point, or that plus side of it is all you just have to do is just go to a particular place and just increase the memory you have, basically to increase the performance. You don't really need to do anything else. You don't really need to stress yourself, learn something else, or kind of edit what you have in your application already. All you just need to do is increase what you have, take it a little bit to a higher level. You understand? So as easy as it sounds, right? You still see there are drawbacks with it, and it's actually far more cost expensive compared to the vertical, compared to the horizontal scaling. is far more expensive compared to the horizontal scaling. Now, horizontal scaling is scaling sideways. What does this mean? We have one initially, and we see that okay, it is slowing down because of there are too many queries coming in at the same time, right? What about if we make it 4, 5, or 6 of the same size, right? We're not increasing the run of the same size, but we're making it 4, 5, or 6. And what we're doing in this place when we make it 4, 5, or 6 is if there are 10 queries coming in, right? Let's just say we have 5 database now, 5 database instance. If there are 10 queries coming in, somebody wants to read this, somebody wants to read that from database, 10 different people. What we could do is 2 people to each database connection. Basically, that hastening the whole process up. You understand? Still almost that same period, that hastening the whole process up, right? But as nice as that sounds, right? We all now know that okay, horizontal scaling might actually be very, very much ideal. But as nice as that one sounds, the little drawback about horizontal scaling is you have to tweak your code to fit horizontal scaling. I might deviate a bit, right, and say something along the lines of there's something called sticky sessions. Sticky sessions, which means if your database is not well connected, I'm going to use an example of myself and let me say a friend I'll call A, myself, Teddy, and a friend A. Let's say, for example, I connect, there's 5 database, right? There's 5 database, and I'm connected to a particular database. And let's say I try to do something on that database, say I edited something on the database, and I knew I have edited that stuff, and showed me it has gone through at that particular point in time. If that database does not replicate, what I mean is since there are 2, 3 copies, their memory is supposed to remain the same. That is, even if I'm connected not to this database, but to another database, if I come back and I'm connected to another database, I'm supposed to see that same thing I edited. I'm supposed to see the exact same copy on the next database, if you understand what I'm trying to say. If it is not there, if that same thing is not replicated over there, then what's the essence of editing it? Do I have to go over and edit it again? You understand? So sticky sessions, read replicas help prevent the likes of that. You can see all this require you to know how to edit your application, do a little bit of touching inside your application, just basically doing a little more editing compared to vertical scaling, whereby you just increase the RAM that you currently have. You guys, you could tell that there's a little bit of difference between the both. Just basically increasing the RAM and just editing the session. So with horizontal scaling, you have to do a little bit more coding in it, right? But it's just generally cheaper than the vertical scaling. That's for one. It is more ideal than the vertical scaling. If you remember initially, I spoke about what, if anything, happened to your database if you're doing vertical scaling. Now, in this case, if anything happens to one database, all you just have to do is continue with the next one, since it has the same thing. So the next one serves as database and also as backup at the same time. You understand? They also serve as backup at the same time because you could just connect to it and to still work with the same connection. I could just basically continue doing what you're doing with almost no downtime. In fact, with no downtime, except especially like very few cases, almost no downtime. Now, those are the 2 major kind of scaling we are going to consider for today. There are other types that are not necessarily here. Other types including caching. Right? Caching means, for those who really don't understand caching, caching just means basically if I had done something before, the next time I do that same thing, I need it to be faster than the first time I did it. Why? Because I expect you to know that, okay, this is the same thing I've done before. This thing should be stored. If you understand what I'm trying to say. So caching is just basically keeping requests that they believe are static. That is, if you go to a website and you're viewing images, you went to the website, the website took 3 seconds to load initially at first. But you then, through that loading, you got images, you got text and stuff. If you go back to that same the second time, it should take you less than 1 second to load. Why? Because those stuff should be cached. That is, since they know these are the stuff you request for frequently, you should just be able to easily access those kind of stuff. Basically, that's caching. You could also implement it as part of your scaling options. There are also other type of scaling. You could do a load balancer. Basically, a load balancer would be very much implemented on what I said on the database. You have 4, 5, 6 database, and there are like 50 people coming in. What a load balancer means is it balances the load, that it balances the traffic. I will divide you guys to this part. There's too much load on this database. You go to that database and connect there. You understand? Basically, that's the idea with load balancing, and just so on and so forth. You understand? So on and so forth. Different kind of scaling, but these are the two major ones we'll be considering for this use case. Please, the next slide. Okay, let's talk on scaling on AWS, right? Most of these things I've actually mentioned them initially. I've made use of them. I've explained quite a few of them. But now I'm just going to go a little bit deeper and just touch on it. So I mentioned horizontal scaling on AWS. I've mentioned horizontal scaling and explained what horizontal scaling means. So now, if you look at what I currently have, you can see in the horizontal part, there are three types, right? There's auto scaling, there's read replicas, and there's load balancers. Auto scaling, what does this mean? Simple. What auto scaling simply means is you don't have to think of scaling yourself. You don't have to bother yourself. As long as you're on AWS, we're going to take care of it for you. So AWS provides that options of taking care of your scaling for you. You have your application, it is currently running, and all of a sudden you have 1 million users coming in. Don't worry, we have you. What we just do is we automatically help you scale from one single database to 50 database, one application to 50 applications at the same time, and you don't need to stress yourself. And the applications will be the same, still connecting to the same, still connected to the same database, and everything will be working seamlessly. No thoughts, no action from you. You understand? That's what it means by autoscaling. There are various types of autoscaling on AWS, and they are almost on every AWS services, basically. They are on EMRs, where you do elastic map reduce on various data sets and the likes. There is on EC2 instances, on servers where you host your application. There is on database, right? There is on database and the rest. We're going to touch on those going forward. Okay, so specifically for database, they are read replicas. If you know about AWS has its own database option, which is Aurora, although it's very much compatible with MySQL and Postgres, right? MySQL and Postgres. AWS provides read replicas for these databases, including I think for this database, that is for this Aurora, MySQL, Postgres, anyone you decide to use. Basically, what does read replica means? Read replica just means that if you create a database on AWS, instead of giving you one single database, you get three. Now, what does those three do? You use one of them for writing into the database, that is for writing all your particularly everything you need, everything you want to write into the database. You want to write a query, you want to save something in the database, all your writes go through one particular instance, that is one particular database instance. Then the remaining are read replicas. And what the read replicas do, you just read from them. That is, they don't write to them, they just read from those replicas. That is, anybody that wants to see what's in the database gets to see it. The call they will make will be to those particular database instance, and it will still be the same thing. You understand? The whole idea behind it is there should not be too much load on that same database that is saving stuff. You understand? So if somebody is reading, it should be different and separated from the one that is actually saving the stuff, saving what you're writing to the particular database. You understand? So basically, that's the idea of read replicas. There is also load balancers. I've made mention of load balancers before, what load balancers does, and AWS has their own load balancer, right? AWS load balancer, and all you just need to do is connect the load balancer to that particular instance you want to do. You want to auto scale, or you want to do a load balancing for to the instances, if they are three, if they are four, the use case might be. You could also connect it to the auto scaling platform, which means the more the scale becomes, like the more the auto scale help you increases your instance, the load balancer also helps you manages the instances that to scaling brings up. Basically, that's the idea behind load balancing the traffic. You also have the option of increasing of scaling vertically. Scaling vertically, basically just increasing your instance type, right? Increasing it from too small to an higher instance type, maybe Graviton, and the rest basically is up to you to decide. Maybe R, maybe M5 medium, just to increase or just to help you improve the performance of that particular workload or of that particular application. Let's talk about specialized workloads. Now we're not talking about horizontal or vertical. Specialized workloads, serverless. Now, remember I said you could connect your auto scaling to your instance and basically help you spins up new application every time. What about if you decide to go serverless? Basically, the whole idea behind serverless is we don't want you to bother about how to scale your application, how to think of anything, how to even patch your OS, that is your operating system, how to edit security vulnerabilities, to edit security patching. Basically, we don't want you to bother about everything. All we want you to think of is your application, and we'll take care of the rest for you. You have that option on AWS. You understand? So basically, serverless is just bring your application, anything you have, be it Django, be it React app, regardless of what you use to provision your app. Even if you want database with it, they see the option. AWS has Elastic Beanstalk, and what Elastic Beanstalk does is you just go to Elastic Beanstalk, put your application in Elastic Beanstalk, helps you configure the database you want, helps you do to scale. You don't really need to take care of anything. All you just need to do is bring your application and we take care of the rest, right? That's the whole idea behind serverless applications. Everything is just, you don't need to bother about any other thing than your application. It gives you more time to focus on your application, helps you scale dynamically. And the benefit of this serverless, right? The benefit of most of them is it's a pay as you go. It's pay as you go. So what does that mean? As long as you have this instance configured, for example, as long as you have one instance on your your application is only running on one particular instance, they are going to be charging you for that one instance. And when there is more traffic and there are like 15 people coming in, and the instance spins up to from one to three instances. Pardon me, excuse me, sorry for that. Excuse me. So as long as the application changes from 1 to 15 users and there are more traffic coming in, basically, what AWS will do is they will increase the application for you. You already know that by now. At the same time, you'll be charged for that increase, right? You'll be charged for using three EC2 instances or using three instances to host your application. And automatically, as that traffic reduces, as people move from your application, it automatically goes down again from 3 to 1. You understand? That's the idea of the auto scaling. But for the serverless, almost still the same thing could be applied. And you only be charged for what you use, that is only for that duration whereby people came and make use of the application that increased the workload, basically. That is only the period you'll be charged for. For the rest of the period, you're not charged. So basically, that's the idea behind the serverless. For microservices is also a specialized use case. Now, microservices is just basically, we're letting you know that what about we divide your application into little parts for scaling. Now, let's say we have an application for orders. We are an e-commerce startup and we have orders, right? People come to make orders. You know, if you're making orders, there are different parts of it. One part is the application, everybody making orders. Another part is the payment, where people pay. Another part is what people see, right? So there is a part that actually controls the feed where people see the goods they want to buy. These three major parts I've mentioned now. The feed that contains what the people want to buy. Another service is taking care of the orders. That is, when you want to make orders, it directs you to that service that takes care of only the orders. And there's also a third service that takes care of payment. Those are three services, right? Those services could also be broken down into microservices. That is, instead of building your application as just one single application, we could help you in CIL. We could help you break those applications into little parts, whereby each part is independent of each other. They don't interact. They don't cause issues with each other. You could just basically do one thing which is totally independent of the other. This one is working fine. That one is working fine. You want to edit something on your payment. You want to increase something on the orders. You want to increase something on the book fee. You could go and touch those without bothering about the other application. Why? Because all of them are separate. All of them are basically microservices by their own self. You understand what I'm trying to say? How the AWS also has a tool called Trusted Advisor. What's the Trusted Advisor? Is an advisor that you trust. So basically, a Trusted Advisor is an AWS tool that you tell the AWS tool, okay, this is what I have on my AWS. Then it explains to you how to better optimize the performance of those particular applications. You understand? Optimize their performance, make the application faster, make reduce your cost optimization, basically. AWS Trusted Advisor, they have a specific service whereby you just put in the workload you have, and it pulls everything from that particular account, checks everything one after the other, and lists out how to actually work on those particular stuff and make it better. If you understand what I'm trying to say. I hope you guys I hope everyone is still with me in this point. Please give me a thumbs up so I know I'm not just talking to anyone here. So that's the idea behind the trusted advisor. You can make use of the trusted advisor. A little bit thing about the trusted advisor though is the trusted advisor is actually based on your plan on AWS. Yeah, I can see thumbs up coming in. Thank you guys. The trusted advisor is based upon your plan on AWS. What does that mean? It means there are various plans on AWS you could do, for example, you could be an enterprise and subscribe to an enterprise, right? Okay. Abbas, I could see your hands up. If you have a question, you could please drop the question in the in-call, in the message part, so I'll be able to respond to it. Okay, so you could actually subscribe to an enterprise, you could subscribe to the basics, and just so on and so forth, right? So it's based on the trusted advisor, it's based on your subscription. I'm not saying you won't actually get it on other subscriptions, it's just that the options you have for the total optimization is based on what level you're subscribed to. But you still also have some option, even though you're a basic user, if you understand what I'm trying to say. So basically, those are the major part of scaling on AWS. There are also other options. If you come in house, what we do as a secure intel is we take a look at your workload and we specify solutions to those specific workloads, right? We specify solutions to help you optimize that your specific workload, be it application, be it streaming data, be it IoT, regardless of what you're doing, right? Even if it is an on-prem, even if it's an on-prem application, that is an application that resides on your own data servers, we have consultants specially that are actually specially trained for that. So basically, please could you go to the next slide? Okay, so on the next slide, I'll be taking you guys through a little bit of demo, right? In the demo, we'll be talking about, we'll just be having a look at the options we have on the cloud. So I'll be sharing my screen now, guys. Just a second. So if anybody has any question, basically now will be the right time to ask your questions on what we've been discussing so far. If you have any questions, if you have any, or if you want to actually consult with us, if you have a particular workload you're currently running and you want to have an insight into that workload. So now I'll be sharing my screen, right? So what I'll be showing you in my screen, I want you, please let me know when if you've seen my screen. If you can see my screen, please, could you just like give me a thumbs up so I'll be able to tell?
Just
And if you
your
want me
screen
to
is up
zoom
now,
in,
Teddy.
okay, my screen is up. Please, if you want me to zoom in, can you see the words clearly? Can you guys see the words clearly? I'm also concerned about that. Okay, yeah, most people could see clearly. So I'm just going to go into it directly. So I'm going to go to EC2. Basically, these are the instances. Then I'm going to use another. I'm going to show you guys the trusted advisor I made mention of. Oh, wow, it's here. And you see the kind of basic subscription that is here, basically. Then I'm going to show you one more thing. I think I'm going to show you one more thing, which is basically the auto scaling. Okay, so along the line, right, something I should have made mention of. If you're building your application, right, your application should go through a couple of testing. The testing are actually quite if you know that much, but there are quite a couple. An example would be stress test, right? Stress test, basically you could test the application just to test out how it works. There's also load testing. So load testing would be basically using tools to stimulate multiple users and what they do. So if they do these kind of things, does it break? What do they do that makes the application break? There's also others around security testing and the rest, basically so on and so forth. But these are actually quite important, including the scalability testing too. You understand? Including the scalability testing, there's also performance testing and just the rest of them, right? There's also a part of it what we call chaos engineering. Basically, you can't tell what might go wrong. As long as it's an application, something is always bound to go wrong. And you're better, in fact, you should be better prepared for something to go wrong rather than it not to. A very good example, Facebook went down, I think, around 2012 or so. I'm not talking about a recent going down. I'm not talking about a recent one. There's a reason I'm pointing a particular example. Facebook, the app itself went down. Basically, something happened to their servers, and they wrote a blog about it. I would suggest, I will try to drop the link of the blog, so just we have a look into that and kind of read on it. Basically, explaining that, okay, this is the idea behind scalability. What they were trying to do is they were trying to scale the application, and between somebody, I think somebody did something wrong there, and everything just went down. And they were able to bring it back up within 4 or 5 hours, which is actually a short time, for a long time, but depending on how you say it. But they were able to bring the application back up within 4 or 5 hours by implementing backups. They've done the testing, they've stimulated situations like this before. So that's the whole essence of the testing. The idea behind testing is, what if this happens? How do we go about solving it? So it's more preferable you run a stimulation of an instance of that, right, where you've tested it out and you know that, okay, if something like this happens, this is how I go about it, than it's just catching you, it's just meeting you suddenly and you're just trying to see how things work around or mitigate the issues per se. So basically, I'm on the instance. If you could see my, let me zoom it. Hope everybody could see my screen clearly. So I'm just zoomed in. I'm on the instance, and you can see these are the instance running: Moodle instance, write instance, test or cloud, Moodle information instance. Pardon that, right? These are just test instances and the likes. So there's something I'm actually hoping I'll test out here, right? I want to come to scaling. So you can see the base auto scaling helps you quickly and easily scale multiple resources. Sometimes you don't even need to use auto scaling. Some services actually have tailored auto scaling on them. EC2 instance, for example, they have something down here. They have auto scaling groups. That is auto scaling tailored to EC2, right? Before we even go into details into that, I think this should have loaded. Let me show you the trusted advisor. So basically, this is the trusted advisor. You could do checks, you understand? You could specify checks, or you could check for Claudio account. Pardon me. Claudio account, you could see cost optimization. This is a very basic account with very basic subscription. You guys how to get water. So this is the trusted advisor, right? The trusted advisor, you can see that's up to, this is a very basic account. This account is just for testing out stuff. Basically, that's what we use it for. So you can see the cost optimization on the trusted advisor. Yeah, there's a lot of things. AWS Lambda provision. You can see various services, right? It checks on all these services and gives you particular use case, help you optimize cost. Okay, you could do something like this so that to reduce the particular cost. Check like this, you could check the settings. Performance wise, does the same thing. You could see DynamoDB, which is kind of like a NoSQL database, block storage, Lambda, well architected. Well architected basically check the whole application. You understand? The auto scaling group, Route 53, your DNS records, and the likes. There's also security. On security, right? You could go into the likes of Amazon EBS, public snapshots, Amazon RDS, you understand? S3 bucket permission, IMUs, and the rest. It checks for security. It checks security wise. It checks, is this account secure? Is this account safe? Can somebody hack into this account? What are the things on this particular account? So basically, those are the checks. There's also port tolerance. Port tolerance in the idea, in the sense of, if your application, if one of the services, if one of the EC2 instance goes down, can it still work? Can it still work? Can we do backup? How long can we do backup? Are we doing backup on database we have currently? All those kind of things. Point in time recovery, how long does it take before we recover everything? Rule 53. Just basically all those kind of things. Service limits. Are you adhering to service limits? What are the limits you have for your service? Operational excellence. When even when doing your what's it called? Even when doing your before you actually consider your scaling, before you doing the consideration of your scaling, you should consider scaling if you have monitoring. So basically, if you have monitoring that is monitoring the services you're using, like an EC2, for example, if the monitoring is telling you, your monitoring is telling you the instance you're using as is using consistently using up to 80% of the CPU. That is using consistently using up to 70-80% of the total storage. You understand? What you should actually consider doing at that instance is scaling out so that it doesn't break. That is it warning you basically. So basically, that's the whole idea of setting logs and alarms and monitoring instances. AWS has their tool for doing that, which is CloudWatch. Basically, watch all your tools in the cloud. So, like I said, we'll go back to the auto-scaling group on issue 2, then we'll test something out. So I want to create an auto-scaling group for a particular EC2 instance. Okay, so I'm going to call it webinar test. I'm just going to call it scaling. Let me call it scaling test. Pardon me, it might actually be, I'm calling it scaling test most likely because I can't spell webinar off my head. So that you guys won't see me using autocorrect. Okay, so there's a reason why I'm clicking on this launch template. Basically, what does this launch template do? Is asking, right? So you guys have a call. Pardon me. Okay, so what does this launch template do? Basically, what does this launch template does is this application you want us to put auto scaling on. If you want to bring out, if you want to create a new instance, right, or a new application, what should we use to create it? How should we create it? What's the idea behind the creation? You understand? Because what we're going to do is what you have here, is what you have on this particular application. That is what we're going to put in that particular application. And if the OS are not the same, that is, if it is what you use to create your application, if it is Mac, right? If your application is currently running on Mac and you don't specify the launch template, and you specify the launch template and say create it on Windows, it's not going to work because basically how the application works on Mac is not how the application works on Windows. You understand? So the whole essence of the launch template is, okay, this application you want or this instance you want us to launch, how should we launch it? You understand? What application, what OS should we use in the launching? And basically that's the whole idea behind it. Okay, so pardon me, I'm just going to go to the instance. I'm going to click on this model instance. This model instance. Okay, so this model instance is running. Okay, what I want to look for is the OS they used to run it. You can see Amazon Linux. That's the OS they used to run it, right? So I'm going to go back to my launch template and say, what do I call that one? Scaling. So I'll call it scaling template. So scaling template. I'm just going to leave the description, leave almost everything, leave the tag. I don't add any tag. So now this is the application. Basically, is an AMI, right? What Amazon image do you want me to use? So I want to go to quick start, right? I want to go to quick start. It's going to give me this is all the options. You can use Mac, Ubuntu, Windows. That the one that I was making use of that I showed you guys there was Amazon Linux, right? Which was basically Amazon Linux 2. So I'm going to click on Amazon Linux. You can see this is Amazon Linux 2023. You understand? But the one I made use of was Amazon Linux 2. Can you see this? So basically, they are going to say anything we're creating, right? We're going to make use of these templates to create it. So all we're just going to do is after creating it, we're just going to move the application from that part to this part. That is, we're going to copy it and drop it here so that anytime the application is coming in, either the user goes to this one or that one, it's still almost the same thing. You still see the same application. You make use of it the same way. That's the idea behind it. So I'm just going to skip everything else. The whole idea is just to show you how it works. Then I'm going to launch. Yeah, I think I selected the right everything. Then I'm just going to launch. So I've launched it, scaling templates. So I'm just going to come back to my auto scaling. I'll refresh to make sure it gets it. You can see scaling template. Then I'll just go to next. Now I'm just going to skip most of this, right? skip everything. They should add it on their own. The minimum required and maximum CPU input, they will add it. Okay. Additional start. This one is optional. This ones are required. Okay, so I'm just going to add only the minimum. Oh, let me see, no minimum, no maximum. You automatically add anything the dim fit. I'm going to instance purchase will be on demand. That is immediately I'm going to buy the instance. Spot instance, if you've worked on AWS before, spot instance means you're testing something out, right? That is, you could buy this instance on the spot, and if somebody else pays the bigger money than you for that particular instance, they're going to shut you down and give it to another person. But it's far cheaper. And because your testing is not supposed to affect you, you understand? But on demand is basically we're going to create that instance for you at this particular point, and it's just going to be far more expensive. But it's kind of like on demand. You can't take it down because you paid for it. You're paying for it as you're using it. You understand? Sorry guys, I have a terrible cough. Oh, it's been affecting me. So lowest price, VPC, just the same thing. Okay, availability zone. Basically, what availability zone means is where should we keep these instances you want to give us? Right? These instances we want us to create. I'm just going to select like three, A, B, and C, right? There are up to 6 availability zones in USS one, A, B, C, D, E, F. You could see, you could select this other one. No, I'm not selecting this other one because it's for a particular, it's for a particular RDS. It's for RDS private subnet, you understand? I'm just selecting this particular subnet that are public, that are defaults, basically. So I'm just going to click on next. So load balancer, you could see you could attach it to a load balancer. It could help you automatically create a load balancer. I don't want to add a load balancer. I just want to show you the application basically. Next. Now this is the part that is interesting for me. This part is group size, desired unit, right? What it's asking you is okay, the minimum capacity you should have. How many minimum application do you want on that particular instance? What's the minimum? I'm going to say trade, for example. If you notice something here, let me just right click this. If you notice something on this dashboard, right? How many instances running? I want to show you the amount of instances running. 4. You understand? So why creating this one? I'm saying I want the minimum capacity at any time, right? At any given time. The minimum that should be there should be 3. And the desired capacity, or the one I would actually like for it to be there, should be like 5. And the maximum capacity, let's say there is even many users, but my money can be more than I can't pay for more than 10 instance capacity. Is this okay? Are we guys getting this? You understand? So basically, the minimum, the desired, and the maximum capacity. But the desired, it might fall below the desired capacity, but at any given time, it should be 3. That should be the minimum that should be available. You understand? So basically, scaling, tracking, we're just going to skip all those. Then we're going to skip next. I'm not adding tags. I just want to create it. Basically, I'm not doing balancers. Then create auto scaling work. You can see it's updating scaling basically. So what does this do, right? Now let's say for example you have your application, right, and you're expecting higher customers. Your application on the norms could have like on the normal ground could have like that's this 3 minimum capacity and this 5 desired capacity. But let's say you're having a Black Friday, like I made mention of earlier. So you want to increase the price, and you want to increase the instance on that Black Friday because you know more people are going to come in and they are going to try price something. There are going to be more people that are going to try to buy something on that particular e-commerce application. You could come and increase this particular scaling group for that period of time. Or you could even configure CloudWatch to actually take care of you. That's where you actually come to consultants on ACA Secure Intelligence that takes care of things like this for you. You understand? What we do basically, we have in-house consultant that does all these kind of things. Fair code, you don't really need to come to the console to touch anything so that you don't mess up your things or you just do things without focusing on the cost because you're charged for what you do, right? We are taught the in-house consultants are taught how to optimize this kind of cost. So I'm just going to refresh. I want to make sure it has provision. Can you see the desired capacity is 5, the minimum capacity is 3. How many instances have I created now? 5. So I'm just going to go to the dashboard and refresh. Can you see? Automatically it's created 4 extra instances of that same one that is running. So if more customers come using and there are more traffic workload, it's just basically going to increase that traffic workload based on the amount of users that are coming in. You understand? So this is an example of the on one of the examples of how auto scaling could actually work. You could see load balancers that I made mention of. There are others that are actually in place, right? And basically, this is how you should build your applications if you're building application on AWS. One last thing I would like to show you will be the Elastic Beanstalk. Like the name sounds, right? It's elastic. You can see you run and manage your web applications. So with this, right, with this elastic beanstalk, is that serverless one I was making mention of. You know, earlier when I made mention of serverless, basically, all you just have to do is bring your application. You don't really need anything. So with this elastic beanstalk, right, all you just do is bring your application. You could automatically create your application. You could see you create an environment for it, put in all the details, tell it what kind of application are you using. Is it React? Is it PHP? Is it Laravel? Is it Code Igniter? Is it Django? Is it Flask? And basically, it configures everything. Tell it what you want it to install in the application. You just list everything out. Basically, you want to connect it to a MySQL or a Progress SQL database and everything. It does everything for you. Then it creates it, then gives you your application at a go, and you make use of the application straightforward, without stress, without any additional use case per se. You could see, and the AWS takes care of the auto scaling for you. If you're using the Elastic Beanstalk, it takes care of auto scaling. As long as there are not much users, you'll be charged the barest minimum. As long as you're not using the application, you just only be charged the minimum cost for like a little bit of running stuff, basically. And when your application is down, and when there are more traffic coming into the application, you automatically increase the size of everything, basically. And that is all about the demo on. That is all about the demo on the scaling. You can see these are the various options. Is it Python? Is it Tomcat? Is it Node.js? Basically, what kind of Node.js you want to run. So let's go back to the slide, possible, where I round up. I hope, does anybody have any question on the, if you have any question on the webinar, basically, or on the demo I just did now, you could actually ask them in the income message or raise up your hand. So please, if you could please go back to the slides. Okay, so like I was saying initially, right? Auto scaling, serverless, just various methods, right? And the testing of the various methods. You have to actually test your applications to make sure the application is working fine as intended. So this is where I actually hand over the mic to Victor. Victor, are you still on call?
Yes,
Okay.
I am. Teddy, confirm if you can hear me, please.
Yes, I can. Please go on.
All right, thank you very much for that robot session. I mean, the quick drive between vertical and horizontal scaling really gave perspectives to some understanding and operational background I think I have before joining today's call. So let's look through if we have questions from our attendees so far. So this is the point where we indulge you to ask questions. If you have questions, can you please drop them in the Q&A box and we will take them one after the other. Okay, Pedro, so there is a question here. Someone is asking, is it possible to implement the two kind of scaling on a particular project? So I want to do the horizontal and vertical at the same time.
It is actually possible to implement it. So you could decide to actually increase the size, then decide to scale it out and say, okay, for every other thing you're creating, I want you to create this particular increased size. But what's the idea of implementing the tool when it's just going to cost you extra, right? Even on servers they use, even Google, I know for sure, even the likes of Google still implement horizontal scaling. Basically, what they do is they get cheaper servers at low cost and kind of have multiple servers, lots of module servers, and make sure they are fault reliant, whereby if one of those servers goes down, another server can automatically take its place with what is on that particular server, basically. You understand? So that's the idea. That's the idea behind it. So as much as it is, right, as much as the whole process it is sounds interesting for you to implement the tool, I would suggest you go for the horizontal implementation. Why? It is less, although it might be a little bit stressful to implement, but it is less cheaper, uh works far better. You also have backups, right? Just it makes more sense to actually go for only the horizontal implementation.
Oh, great. Interesting. Interesting. I hear you on that. I hear you on that. Whilst it's possible to use those two models you've advised on, which one would be your preferred choice? And you've given reasons for that choice also. Thank you very much. Do we have any question here again? Let me look through. Let me look through. So someone is asking, is it a must I scale up my application?
Yeah, okay. Scale up means vertical scaling. I would like the person to know scale up means vertical scaling and scale out means horizontal. So if you are you referring to the scale up, scale out, or you're referring to the both of them as is it necessary for the both of them? Well, if you're a startup, right, or if you're just building the application for fun, you're just testing it out. And it's also nice to also test those kind of things out. But if you're a startup and you basically if you don't plan for scaling and you're a startup, you're just saying what he's just saying is, I'm just testing this out. I don't think it will work, but I have enough money to throw. So let's just play around with stuff. And if you consider yourself a startup. So if you're a startup and you're willing to actually go all the route, right? These are the things you plan for even before you start. Because definitely you should have customers coming in. How do you maintain this kind of customers? How do you make sure it works well? All applications face this kind of thing. At the earlier versions of Twitter, 2006, 7, 8, 9, especially towards 2008 and 9, they were consistently having issues with scaling because they didn't plan for it. It was consistently going down. Every now and then, it was consistently going down till they were able to decide to say, okay, once and for all, let's just get this kind of thing straight. And they did it once and for all. You understand? So scaling is a very, 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 very essential factor to your application, as the use case might be. Or everybody faced it at a particular point in time. But the only one I would say, okay, actually try to mitigate it a bit, even though it went down at a point, would be ChatGPT, like I made mention of. Between 3 days, a million, within how many days, 15 million. And at a point in time, it actually went down because they were way too much than they could handle, way too much than they thought. But they were able to scale to that particular amount. Now imagine if they had not planned for scaling or they didn't even plan for scaling at all, like you made mention of. After the first day, and the users went from zero to, let's say, 100,000 or 500,000, and the application went down and they didn't plan for scaling, which means they have to restart everything again. People would lose interest, and people losing interest if you're a startup, basically that's the end of it. You understand? Every customer matters at the initial period. That is one thing you should know.
Oh,
So
thank
it
you.
is
Thank
very
you.
important.
Thank you very
Thank
much.
you.
Thank you very much. I mean, you just gave a very strong point to business owners here. And for those of us who might want to ask further questions as regarding scalability on AWS, a link has just been dropped for you to schedule a session with our consultant for free. You jump on a call with them and they would provide answers to your questions, extensive answers to your questions, and we would then get to see how we could work things out for your startup and position you for global success. It's been a wonderful session having Teddy run us through today's webinar. Thank you very much, Teddy, for such a robust and insightful session today. We hope we will get to have you on the session, on the webinar in the closest future. This is where we draw the curtain on today's webinar. A big thank you to everyone who has joined us. Like I said earlier on, today's webinar has been recorded, and keep an eye for sessions that would be very helpful on our social media platforms, and also recordings will be shared with us in the shortest possible time. Till I come your way the next time, see you, and ensure you close up the gaps and tighten up the loose ends, and ensure that there are no downtime with your applications. Enjoy the rest of your day. I remain Victor Ademola from Secure Intelligence Limited. See you soon. Bye for now.